Hi students, today we'll start the problem solving technique and heartily welcome to lecture series 2. So already we discussed these things, right? And we have discussed it up to special cases, that is generalizations and as well as special cases. And today we'll continue the classes with the lecture series 1 to lecture series 2. In this class, we'll discuss about the types of computational problems over here, right? Let us see what you mean by computational problem. It is a problem that can be solved step by step with a computer. These problems usually have well-defined inputs and constraints and conditions that the output must satisfy, right? So here is a solution that should be solved by the step by step with the computer. Generally, this problem usually have some well-defined inputs we have, some of the constraints we have here, and some of the conditions also we have here. And these inputs and constraints and condition must satisfy, right, for the output. That is what exactly we say it is a computational problem. So here is the sum of the types of computational problems. The first one is a decision problem, a search problem, a counting problem, a optimization problem. A decision problem is a one where the answer is in terms of yes or no statement. Yes or no statement, that is called a decision problem. For instance, given a number n, right, is n even? That is nothing but whether the number is given is n is even or not. Right? Yes or no statements, that kind of statements are called decision problem. Is a decision problem. Some decision problem take more steps to solve the others than the others. For instance, given a number n is n prime, takes more steps that just checking the part of the number. So yes or no statement, whether the given number is prime or not. To find these kinds of statements are called as a decision problem. Next, a search problem. A search problem is a one where the solution consists of one or more values. Solution consists of one or more values that satisfy a given condition. So it's nothing but it consists already we have more than one values. Those values must satisfy the given condition. Right? We may want to compute a path from one geographical location to the another on a map. So that is the example we need to say here. So we have some of the one or more values. We need to find out we need to satisfy the given condition. Given conditions, whether the greater than or equal to, lesser than or equal to, these kinds of the things we have here, a searching problem over here. Third one, a counting problem. A counting problem is a one where the answer is the number of solutions to a search problem. Where the answer is the number of solutions to a search problem, that is called as a counting problem. So here we have a number of solution. Here we need to find out a problem, that is called to search a problem we need to say, that is counting problem we need to say. Next, an optimization problem is a one where the solution is the best possible solution, where the best can be defined is the defined in a different way. For instance, we may want to compute the fastest route from one location to the another. It is nothing but we need to optimization problem in the sense, supposing that we want to reach somewhere else from a source to destination. If you want to reach from source to destination, right, we may pass different kinds of n of nodes over here. And here we need to find out from source to destination, which is the easiest way to move to the destination. We need to find out the best way to reach as earliest as possible. That is called the best solution. That is called and best optimization problem we need to say. These are all a problem where we can able to come across with the computational problem over here. Next, a classification. Next, a classifications of a problem. A problem can be classified based on various criteria depending on the context, such as difficult, type, or domain. Here is some common classifications used in computer science and problem solving. That is nothing but you might have seen in the data structure, complexity, right? Which is the best and shortest path algorithm, BFS, DFS, right? Here, based on the complexity, the tractable problems, intractable problems, undecidable problems. These are the three which are based on the complexity. Complexity is in the sense efficiently, which is able to solvable, right? That is tractable problem irbodu, intractable problem or maybe there, or undecidable problem may be there. Problem that can be solved in a polynomial time. Problem that can be solved in polynomial time often require exponential time. Undecidable is nothing but problem for which no algorithm can decide the solution for all inputs, right? So these are the three which are we can see in terms of the complexity. If it is in terms of the natured base, we need to have a three. Again, decision problem, yes or no statement. That kind of answers are called as a decision problem. Optimization problem is nothing but we need to find out the criteria. They will provide some of the criteria. We need to find out which is the best one to reach the solution. That is called optimization problem. Third one, search problems that requires finding a solution from a set of possible solutions. Already we have some of the solutions. In that we need to find out the which is the best solution. Next, based on the domain, mathematical problem, logical problems, computational problem. Mathematical problem is nothing but it involves the number, equations, and mathematical structure. But when you go for logical, it involves logical and reasoning problems we have here. And third one, computational problems we have involving algorithms and computations. And the last one, based on the problem structure, well-structured problem, problems with clear goal, constraint, and solution path. Solution path and structured problem with unclear goals or solution. These are the four classifications of problems over here. That is on base of complexity, on base of nature, on the base of domain, on the base of problem structure. Next, we will see the next point here is we have here analysis of problem. How to analyze the problem, right? The problem solving techniques are a method or a strategies used to find a solution to complex or a simple problems. Several common problems can arise during the process of problem solving. Understanding the problems helps improve the effectiveness of problem solving. Here are some key issues often encountered. So here are some of the problem when we are providing the solutions in terms of the complex or very simple problem. So some of the problems can be arise during the problem solving techniques. What are the problems we can come across in the sense? First, poor problem definitions. That is nothing but a problem doesn't define any kinds of a definition exactly what kind of solution I need to provide for that one. So incomplete problem. That is called poor problem definition we need to say here. Not clearly understanding or defining the problem can lead to solving the wrong problem. It is important to analyze the problem carefully and identify the root cause. Lack of information. Without knowing some of the problems, the problem cannot be analyzed and we cannot know the some of the data without knowing some of the data how to solve this problem. That is called lack of information we need to say. That is insufficient or inaccurate information can hinder the ability to find the good solution. Without knowing the information regarding the problem, we are unable to find the good solution. That is called lack of information. Next, gathering the relevant data and fact is essential before attempting to solve the problem. Here, nothing but without knowing the problem, right? If at all you have something that you have a problem, but you don't know the background of the problem, what kind of problem it is. If you know the problem, how to solve it, then definitely you can able to solve that problem, right? So supposing that we have some of the mathematical problem, integration or calculuses. If you know that problem should be solved in terms of the some of the theorems, definitely you can use the theorems and you can able to solve those problems over here. But if unknown person if you give those integration or calculus problems, definitely you don't know how to solve that one, because you don't know the what kind of theorems and what kind of things should be used to solve this algorithm. That is what exactly we say. It is the first lack of information we need to say. Third one, cognitive, that is biases, that is personal biases or assumptions can affect judgment and decision making. Being aware of biases like confirmation bias or anchoring can help avoid errors. Fourth one, inadequate plan. So plan should be done over here. So plan on which basis we need to say, without knowing the biases, information and problem definition, it is very difficult to identify the solution. Sometimes if at all you solve the problem, it is an inefficient or an incomplete solution we need to say here. Right? So these are the way of analyzing the problems in terms of the problem solving techniques. And the fifth one, over complicating the problem. So you know that if the problem is known, if you are very familiar, you definitely will solve and you try to gather some of the information. But when you, without knowing some of the problems, sometimes the problems are made more complex than they actually are. So some of the problems look like easier, but when you go for solving that problem, it is very, we will face uh, lot of problems when you solve that particular solution for that one. And simplify the problem can make it easier to solve. Next, lack of creativity maybe, failure to evaluate the solution, and resistance to change. So these are all our 8 problems we can able to come across when you solve the particular problem solving, right? Finally, we can conclude that an effective problem solving requires clear problem definition. Of course, without knowing the definition, clear problem definition, we are very difficult to solve that problem. And gather the sufficient information and planning, make the plan to solve that one, and make the some of the creativity, which is the best way to solve that problem, and evaluation of that solution. So being aware of the common problems in the process, helping in the applying problem solving techniques more successful. So these are the things we have been learned in the analyzing of the problem over here. And the final topic in the lecture series, that is called solution approaches. What kind of solution should be given for that problems? Generally, the problem solving involves identifying a problem. First, we need to identify the first approach, analyze it, finding the effective solution. Right? These are some basic identifying the problem solving over here. Here are some solution approaches used in problem solving. First one, make the trial and error basis. Apply some basic algorithms for the particular problem. Trial and error, try to different solution until one works. Useful when there are few possible solutions. When you use algorithms, some of the algorithms should be followed by the step-by-step procedure, or some of the guarantee solutions if the algorithm is correct. Heuristics approaches use the rules of thumb or educated guesses, faster but may not always find the optimal solutions. Divide and conquer method we supposed to use in these solution approaches, that is breaking the problem into n number of smaller and manageable part. Solve each part individually and combinational, that is combined result only. So these are the solution approaches are learned in terms of approaches. And working background, that is backward, starting from the desired solution, working back to the given data, useful in puzzles and logical problems. That is nothing but whenever we go for solution for a problem for that one, first find out whether we have learned or we have some data previously exist or not. That kind of should be done in terms of the working background. Brainstorming, that is generating many ideas without immediate judgment. So without knowing the problem, just directly we are judging that these things should be getting output. So these kinds of assumptions should not be done in terms of brainstorming. Encouraging the creative solutions. And analog, that is applying a solution from a similar problem to the current one. And the last one, simulation, the modeling the problem and experimenting with the different scenarios. So these are all are the different approaches where we are applying for the particular problem solving techniques. So finally, we can conclude that each approach can be chosen based on the nature of the problem, available information and time constraint. These are the approaches on which basis we need to choose on the nature of the problem and what kind of data should be available information and how much time, that is time constraint, we need to say here. These are all are some basic approach we need to learn before solving the problem. So these things we need to learn in the steps. And another thing we have here, that is called algorithm development. Our algorithm development process consists of 5 major steps. First one, obtain the describe the problem, analyze the problem, develop a high level algorithm, or refine the algorithm by adding more details, and last one, review the algorithm. These are the 5 steps we need to develop the algorithm for the problem solving techniques. So let us see what do you mean by step 1, obtain the description of the problem. So name itself indicates that first we need to take the problem descriptions. Whether the problem describes something else, that should be data should be taken over. That is, this step is much more difficult than it appears. In the following discussions, the word client refers to someone who want to find a solution to the problem, and the word developer refers to someone who find a way to solve the problem. This is called a client and developer, the difference. Client whom say someone who want to find a solution to the problem, but when we say developer refers to someone who finds a way to solve the problem, right? So custom client will finding the solution to the particular problem, but developer will find the way to solve that problem. The developer must create an algorithm that will solve the client problem. This is the way of obtaining the description of the problem. Second step is analyze the problem. Of course, without analyzing, we can't able to solve the problems. Purpose of this step is to determine both the starting and ending point for solving the problems. This process is analogous to the mathematician determining what is given and what must be proven. A good problem description makes it easier to perform these steps. That is, when, what, where, what. So these are the question should be analyzed when we analyze the problems, right? And when determine the end point, we need to describe the characteristics of solution. In other words, how will we know when we are done? Asking the following questions often help to determine the ending point. What new facts will we have? What item will have changed? What changes will have been made to those items? What things will no longer exist? These are the things, these are the questions that helps to determine the end point. That is called analyzing the problem. And the next one is develop a high level algorithm. So developing the high level algorithm on which basis? On the problem and analysis basis. So here is on an example, the problem I need to send a birthday card to my brother. That is called Mark. Analyze nothing but I don't have a card. I prefer to buy a card rather than make one myself. Right? Card non modakina better I need to prefer on buy to buy a card, right? So I need to build an algorithm for this one. Go to the store that sells greeting card, select the card, purchase a card, mail the card. This is the step where I provide the higher level algorithm. This algorithm is satisfactory for daily use, but it lacks details that would have to be added where computer to carry out the solution. These details include answer to the question such as which store will I visit? That is not present in the high level algorithm. How will I get there? Walk, drive, ride my bicycle, take the bus. So these are the questions arise when you go for high level algorithm. And what kind of car does Mark like? Humorous, sentimental, or risky? And these kinds of details are considered in the next step that is called the next step. Refining the algorithm by adding more details. More details in the sense, just now we have seen that some of the high level algorithm are already generated, but these are the questions are asked when you come across this algorithm. So that should be seen in the high level algorithm shows the major step that needs to follow the solution of the solvable problem. Now we need to add details to these steps, but how much details should we add? Unfortunately, the answer to this question depends on the situation. Of course, without knowing the situation, we can't judge the algorithm. Where should the candidate should buy which store? The store should be nearest or far away from where should he need to visit? And to visit that store, whether he need to take the bus or he need to take the ride or he need to take the some vehicle, personal vehicle. These are the questions are depend upon the situations, right? So that is called refining the algorithm by adding more details. Next, step 5, review the algorithm. Final step is to review the algorithm. What are we are looking for? First, we need to work through the algorithm step by step to determine whether or not it will solve the original problem. These are the things should be verified in terms of the review in the algorithm. Does this algorithm solve the very specific problem? Does it solve more general problem? If it solves a very specified problem, should it be generalized? These are the things are should be think when we go for reviewing the algorithm. So this is the all about that is your algorithm, and here is one example, so you can able to understand the concept over here. Supposing that we have an algorithm that compute the area of the circle having radius 5.2 meter. Formula he has given is formula pi into 5.2. Solve the very specific problem, but the algorithm that computes the area of any circle pi into r square. Solve the more general problem, right? This is specific problem, this is general problem. Let us take this. Can this algorithm be simplified? Right. One formula for computing the parameter of the rectangle is length plus width plus length plus width plus, right? And a similar simpler formula would be 2.0 into length plus width. Is this solution similar to the solution to another problem? These are the questions should be arised when we are picking the these computing area of the circle. If it is a different, then how are they are different? Everything should be checked over here. For example, consider the formula with the two formula, that is rectangle is equal to length into width, triangle is equal to 0.5 into base into height. These are the two formulas where we can able to like similarities, difference, hypothesis. These are the things should be applied when we go for these kinds of different two formulas. So this is all about your a algorithm development, right? In the next class, we will see the what kind of the things we need to learn in the right. That is called as we say analysis of algorithm, efficiency, correctness, role of data structure in Python in the problem solving. These topics should be covered in the lecture 3. So we will see you in the lecture 3. I hope this video will helpful for your this academic. If you have any doubts, kindly comment your problems in a comment box. If you like this video, definitely will share with your friends. Right? Okay then. Thank you. How?